So in this episode, we're going to look at atom economy. Now, the atom economy is of a reaction describes the percentage of the reactants that end up as useful products. And now to calculate it, we can divide the relative molecular mass of the desired product by the total relative molecular mass of all reactants, and then multiply by 100. So I'll say that again. The relative molecular mass of the desired products divided by the total relative molecular mass of all reactants times by 100. So just to recap that, which term is used to describe the amount of reactants that end up as useful products? Well, that is exactly what we've just described. It's the atom economy. Now, just to run through an example, if we've got the molecular mass of the desired product as 10 grams and the molecular mass of all reactants as 20 grams, let's talk through how we'd change that into atom economy. So remember that the equation for atom economy is the molecular mass of the desired products divided by the molecular mass of all the reactants times by 100. So if we substitute the values in there, the molecular mass of the desired product is 10 grams and the molecular mass of all reactants is 20 grams. So if we do 10 divided by 20 times by 100, that will give us 50% atom economy. And all that means is that 50% of the atoms that are within 50% of the mass of the atoms that are in the reactants turn into useful products in the reaction. So reaction pathways, which are ways that reactions happen with high atom economies, are good for two reasons. First of all, the cost. So the smallest possible amount of reactants leading to desired products will save money in a reaction. It also reduces waste. So a higher atom economy will mean that less waste is produced. And when choosing a reaction pathway, we don't just consider atom economy. So thinking about those costs and those wastes, we also might consider what the reactants would cost, the percentage yield of those reactions, how fast the reaction is or the rate of reaction, how useful the byproducts are, so maybe we could use those in other ways, and the position of the equilibrium. So how easy is it for this reaction to occur, and does the reaction constantly reform the reactants again from the products? And just go back to how useful the byproducts are. If you think of a classic example that you might have in your home is Marmite. So Marmite is the byproduct of a process involving yeast. So that is a useful byproduct that can be used and sold on by companies. So reaction pathways with high atom economies are more cost effective and produce less waste. And why are reactions with high atom economies good? Well, they produce less waste and they save money. The atom economy of a reaction is 50%. If the molecular mass of the desired products is 6, what is the molecular mass of all reactants? So it's 50%, that means 50% of the mass of the reactants turns into useful products. So we've got 6 grams of or molecular mass of 6 for the desired product. So 12 halved gives you 6. So it'll be 12 will be the molecular mass of the reactants. So a couple of benefits of selecting reaction pathways. So first of all, you've got minimal waste, and secondly, you've got minimum cost of reaction. So that's two things you need to consider. And finding ways to make the waste products out of chemical reactions useful can increase the atom economy.